I think I'm live now. Can anyone confirm if audio, video, and everything is fine before we get started? Hello, hello. Hello, hello. Can anyone confirm if audio and video is fine and if you are able to hear me? Okay, was able to solve 4 equally. Okay, thank you. And like people in the chat, like how many problems were you guys able to solve? Mhm. Okay, 4, 5. Like I found like the last problem much harder than general D3 problems. So yeah, like that's where we are. Okay, E was familiar. Yeah, I think so. Yeah, like by the way, I am also experimenting with Twitch this time. So if you prefer, you can also join in there. So that's where we are. Okay, I did 4 problems. Yeah, I think I will wait for a minute more and then I will get started. Was it related to connected component? Yes. Yes, E was DSU. Like. Okay, I think I will start now. So there is an array of 5 integers. Initially, you know A1, A2, A4, A5. You may set A3 to any positive integer, negative integer, or 0. The Fibonacciness of array is number of integers are such that AI plus 2 is equal to AI plus 1. Find the maximum Fibonacciness over all the values of A3. So like let's briefly discuss what does the problem statement ask us to do. Okay, I am using Chrome and but the software is R3 Window Manager. Okay, yeah. So like the problem statement goes like this. You have an array A of 5 integers 1, 2, 3, 4, 5. This value is fixed given to you. This value is also fixed given to you. This value is fixed. This value is fixed. You can choose any value here. And then you have to count how many Fibonacci pairs exist. And you notice here like this pair would be a Fibonacci number if A3 is equal to A1 plus A2. This pair would be a Fibonacci if A4 is equal to A3 plus A2. And like this pair would be a Fibonacci if A3 plus A4 is equal to A5. So like you can notice that in 5 numbers, there can be at max 3 Fibonacci pairs. And the idea can be like you just look at value of A1 plus A2, then difference of A2 and A4, then difference of A4 and A5. And like you will get 3 different values of A, 3 different values of A3. And you can choose the value which increases like the have the maximum number of pairs. This is one solution. And in contrast, what I did was like you can notice that like all the numbers are between 1 to 100. So like A3, like if A1 plus A2 is a pair, then this will hold and this should be less than 200. Similarly, like for example, like you can even notice that here, like if this is less than equal to 100, if this is less than equal to 100, then this can be like, if this is more than minus 100, like for example, like this is less than equal to 100, this is less than equal to 100. In worst case, let's say this is 100, this is 0, then you need minus 100 here. So what you can also do is try out all the values of A3 between minus and A3 to 200. And like that can be your solution. Like just iterate on all the values from minus 100 to 200 and just check how many values each of them gives you and just count the value and print the maximum. That's what I ended up doing in the contest. Like just checked all the values between minus 500 to 500. Like I will briefly show the code. So this was my submission. Like I array of 5 integers, and for A to try out all the values between minus 500 to 500 and take the maximum value, where get is the function which takes an array and count the number of Fibonacci pairs, which is A0 plus A1 equal to A2, A2 plus A1 equal to A3, and so on. So essentially this was the solution. Any question, anyone, before we move to the next problem? So this was the idea for the first problem. I will probably move to the second problem then. Farmer John's card game. Farmer John's and cows are playing a card game. Farmer John has a deck of n into m cards numbered from 0 to n minus n into m minus 1. He distributes m cards to each of his n cows. Farmer John wants the game to be fair, so each cow should only be able to play one card per round. He decides to determine a turn order determined by a permutation p of length n, such that pith cow will be ith cow to place a card on the top of the center pile in a round. In other words, the following events happen in order in each time. P1th cow places any card from her deck. P2th card places any card from the deck, and similarly Pnth card places any card from the deck. There is a catch. Initially, the center pile contains a card -1. In order to place a card, the number of card must be greater than number of cards on the top of the center pile. Then the newly placed cards become the top card of the center pile. If a cow cannot place any card in their deck, the game is considered to be lost. Farmer John wonders how many does there exist permutation P such that it is possible for all cows to be empty, their deck playing all m cards of rounds again. If so, output any P, otherwise output -1. So like this was the problem statement. No, I doubt -100 to 100 will work on the first problem, but you can always check it. Like it may potentially work if we can prove that for any number greater than 100. Like so, like this is the problem statement. It says, for example, let's take one of the input as well. 042153. Like probably like I will go through all the problems. Like let's first say like there is some order of cows here. Like this is the first cow. Let's say this is the first cow. This is the second cow. Like let's say like cows play in this order. This plays a second cow and this is third cow. Then you know that you have all the numbers between 0 to n into m -1. Like there is no missing number here. And at any point you will keep playing the numbers which are in increasing order. So like the deck will look like this. Initially there is -1, then someone will play 0, 1, 2, 3, 4, 5, 6, 7, 8, and so on. Like this is how the numbers will be placed here. So if this is the order of the cows, then you can notice that the first cow will play 0, the second cow will play 1, third cow will play 2. Then the turn of first cow will again come in. So they will play 3, 4, 5, 6, 7, 7, 8, 9, 10, 11, and so on. Like this is how the turns would be played. So like one of the cow must have numbers 0 and 2n and so on. One of the cows must have numbers 1, n plus 1, 2n plus 1, and so on. And one of the cows must have 2, n plus 2, 2n plus 2, and so on. So now, once you realize this, what you can probably do is like you can just sort all the numbers in each row. Like because like any like if cow is, let's say this is a particular cow. Let's say cow has number 10, 18, 14. Then in the first run, like cow must play the smallest number. Let's say in the first run, if cow has played 14, then the next time if cow plays 10, like the same cow itself will end up violating the condition we need. So like that's the idea here. Like each cow will first play the smallest card, then the second smallest, third smallest, and so on. So like this would be the idea. Like now you can try out multiple things. Like you can just sort out all the numbers and note ensure that each difference of each number for each cow is equal to n. And then you can look at the sorted order of the smallest number and you can print the numbers in that order. Like whoever has a 0 would be the person to play first. Whoever has the 1 would be the person to play second. Whoever has 2 would be the person to play 2, and so on. And essentially this was the solution I had. And like I think like now you can try out different ideas, but yeah. And I think in contest what I did was I found the order and then I ended up doing, but I think I will just show out the code here. So like this would be the idea. Like what you can do is you can look at all the numbers. For each number you can like if is valid is false, just stop processing here. Otherwise sort all the numbers. And for all j, if difference of aij minus 1 plus n is not equal to aij, then is valid is equal to false. Otherwise, if current sequence is not valid, break it. Now, like let's look at the smallest number of this card, and that would be this cow's turn. And this is all you need here. If the sequence is not valid, print it. Otherwise, just print the sequence here, 1 to n, and that is the solution. Okay, like let me look at the questions in the chat. Like for the first problem, just check twice. First number a2 equal to a1 plus a0 and a2 equal to a4 minus a3. What about like what about a5 equal to a4 plus a6? Like the number, like the array only has 5 numbers. So A0, A1, A2, A3, A4 would be the inner 5 number. You will never have A5 because that's the 6th number. I calculated A1, okay, and just checked how many of these are equal. If equal, then the answer is 3. If 2 equal to, and yeah, like that essentially works. What about max time complexity of B? Like I think the solution I have proposed essentially ends up being order 1. Like you have 3 different numbers to check for, and that's the constant time. Okay, B I did similar. I thought same. Tried replicate order. Yeah, like I in fact, if you look at my in contrast submission, I tried to replicate order and everything, but this is order. Okay, yeah, and I think E was DSU browser. I think I am using Arch Linux with i3 window manager, and this is Chrome browser. Okay, I think I will come back to E and F later on. How do I make, like, I think I can probably answer it towards the end of the stream. Okay, like what will be the rating of this problem? I think you can just check clist.by. Like they publish the rating for every contest based on how people have solved it. So you can just look at this. Like they are right now refreshing the rating here, but once they are done, but that's all you have. You can find it here. Okay. So okay, I think this contest might be a mirror of some another contest, or probably I'm not sure, but that's where we are. Any questions? Anyone on problem B before we move further? Okay. Look, I was assuming there is a hacking phase here. Like, is that not the case? Okay, there is a 12-hour hacking phase, right? Okay. Okay, I think I will probably move to the next problem then. Game of Mathletes. Alice and Bobs are playing a game. There are n, where n is even integer written on the blackboard, represented by x1, x2, x3 up to xn. There is also a given integer k. Integer scroll that is initially 0. The game lasts n by 2 turns in which the following events happen sequentially. Alice selects an integer from the blackboard, erases it. Let's call the Alice chosen number by A. Bob selects an integer from the blackboard, erases it. Let's call Bob's chosen number by B. If A plus B is equal to K, add 1 to the score. Alice is playing to minimize the score while Bob is playing to maximize the score. Assuming both players use optimal strategy, what is the score after the game ends? Okay, so like the game is defined as follows. So it says you have 2 n integers. Let's probably pick one of the samples here. Let's pick these numbers. 1, 3, 4, 4, 7, 5, 5, 3, 6, 6, 3, 3. Let's say these are the numbers. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers. And let's say k is equal to 8. Then let's first count what is the maximum number of pairs we can form that have sum 8. Notice that for any number f, any number x, the another required number is x minus k. So for each number, like there would be a unique pair which makes sum k. And let's try to count pairs like this. For example, let's take 1 and 7. They sum up to 8. Let's take this 4 and 4. Let's take this 3 and 5. Let's take this 3 and 5. So we have got 4 pairs here. 1, 2, 3, 4 pairs. So what Bob can assume, so we know that answer can never be more than 4 because we have only 4 pairs which sum up to 8. And what Bob can do is Bob can always ensure that the answer is 4, and Alice will have no choice. Like what Bob can do is he can pair 4 numbers like this, and he can randomly pair remaining. Like basically, Bob can make n by 2 pairs. Such that the number of pairs with some k is maximum possible. And the Bob's idea is whenever Alice plays one of the number from the pair, in Bob's turn, Bob will play the another number instantly. Like for example, like the remaining numbers made by Bob is like this. Like let's say Bob has decided like this would be the pairing. Then the idea is, let's say Alice has played this number. Then Bob can instantly play the other pair he has chosen. Let's say Alice plays this number then Bob can instantly play this number to make some k. And like Bob can always decide, and other way around, like let's say if Alice plays this number, then Bob can play this number immediately to make some 8. So like once Bob has decided what n by 2 numbers pairing should be at the end of the day, Alice will never have a choice that he can change those pairing there. Because for every pairing there are 2 numbers. Whatever Alice plays, Bob can instantly play the opposite number. So that's where we are. Like we can find what are the maximum number of pairs. And like because like you have 2n numbers, like you have n numbers where n is even, you can never have unpaired number. Like you will always have n by 2 numbers. And yeah, I think this was important one. Yeah, n by 2 pairs, we will always have these pairs, and there will never be an unpaired number. No unpaired number. Yeah, I think this was critical one. Thanks, Northern Come. Yeah, like, and like that's what make it difficult for Alice. Let's say if there was unpaired number here somewhere, let's say, and if that would have happened only if n was even, then whenever Alice would have played this, Bob would not have any chance to make another pair, and that would have spoiled Bob's plan. And I think a lot of people might have missed it. Like it's explicitly written n is even, and here it's also like sometimes it's important to look at the constraint. That's why. Hello. Mike, let me check. Hello. Okay. Yeah, like that was the main idea. And I'm not sure why Python is giving TL here, but you might have to check on it. So like this was essentially the idea for this problem. And now the idea is like how do we find maximum number of pairs? What we can do is like for each number we know that x and the another remaining number is k minus x, right? So if we know the like how many times each number appears, then we know for a number like this, number of pairs you can form is minimum of count of x comma count of k minus x. Like that would be the number of pairs you want. There is only one edge case when let's say x equal to k minus x, basically x equal to k by 2. In this case you can only form count x by 2 pairs because same number would be used twice to get one pair. And essentially this was the solution I had. Like now you can probably first maintain the count of each number and then try to do it. Or another way to do it is like you can just maintain whenever you read a number, you just check k minus x is present. Then increase your count plus plus and ignore the new number x you have read. Otherwise, you just add like frequency of x, and like that was my solution here. And that is the solution for this problem. Any questions, anyone? Like, I think I will quickly show you the code. Like, one important question and constraint was like all the numbers are between 1 to n only here, so we can maintain one array of size over here as well, size of. Like, you can just maintain 2n because x is up to k only. You read n. If f of k minus x is present, you decrease that by 1 and increase your count. Otherwise, you increase x over here and you can print whatever pairs you have got. Like, you can probably also use the 2 pointer here, like that will also work. Like 2 pointer also works. Like the solution would be similar to 2 sum problem. Like, you can probably try out this problem as well as a homework problem. The problem asks you to find one pair which has sum given equal to current number, and you need a slight modification of the solution here. So, any questions, anyone? Before we move to the next problem. Okay, I think I will probably move further as well. So, wait, runtime error on test 2. Like 1 second, what mistake I ended up making? Okay, 1 second. All the numbers are between 1 to n. Oh, wait, this can be negative as well. Like, can never form pairs like this because each number is between 1 to n only. So, yeah. Like, you should always ignore the numbers where k minus x or n minus k is always greater than. Yeah, like pretty tricky one, I guess. Yeah. So I think subtract means sort. You are given a sequence A consist. Okay, I think I am back. Like, my battery died. 1% here. So, like, am I audible, everyone? Yeah, like basically the battery died 1% right now. So yeah. Yeah, like okay, so the fourth problem is subtract means what? You are given a sequence that consists of n positive integers. You can perform the following question operation any number of times. Choose an index I, subtract minimum of both values from both the values. Determine if it is possible to make sequence non-decreasing by using operation any number of times. So this is the problem statement. And yeah, like basically yeah, like basically the idea here is no, like the DSU in E definitely works. Just that it depends on how to do it. We have number, let's say A0, A1, A2 up to AN minus 1. And first thing to notice is like let's also take one of the example. Just give me an array of 5, 6 numbers. I will play around with that. Okay, 2, 5, 5. Okay, let me pick this one. 3, 1, 4, 7, 8, 6. Okay, let's say like we pick this number. What happens after we pick these numbers? We will have to subtract from both. So this number will become 0, this number will become 1. And now notice that whenever you apply operation on this number, nothing happens. And like because this is 0, you will have to also make all of these numbers 0 here. You have no other choice because that's how the number would be in increasing order. Like non-decreasing order means the order should be sorted order. And now like you can probably try out playing here, but you will realize that you will never be able to make this 4 0. So doing the first operation here is a bad move. Like wherever you, like whenever you do one operation, one of the number becomes 0 instantly. And after that, every number, any number which is before it should also be 0. That's how you will end up with the sorted order. So now, like now this gives us an idea. Like first time whenever we do an operation, we should do an operation here only. We have no other choice. And if we do an operation here, this ends up being 0 and 1. This ends up being 0, this ends up being 2. And now you can probably never do anything else here. The answer will be no here. Like let's probably take one of the answers where the answer is yes. Like basically the idea is first time you do an operation here so that this number becomes 0. Then you do an operation here. Then this number will become 0. Then you will do an operation here. This number should become 0 and something like that. You can keep doing it. And at last, this will also be 0. And this can also be 0. Like if you keep applying operation on increasing order like this, and then you can have some positive number or 0 anything here. And if you end up making an array like this by doing operation at like first I equal to 0, I equal to 1 up to I equal to n minus 2. After that, you can just check if all the numbers except the last number should be 0. And the idea is like whenever you came up with a condition like this, like let's just pick some of the number from the array only. 4, 5, 4, 5. Like the idea is like let's first do an operation on the first number. Here this 4 will become 0. This 5 will become 1. Now you do an operation between these two numbers. Now you do operation between these two numbers. This will again become a 0, and this will become 8. Now you see, like, if you do an operation here, this number will become 0, while this will remain 6. So in the cases like you keep doing operation from starting, and whenever it happens that AI is greater than AI plus 1, you stop there. And then you see, like, if the array has automatically become sorted or not. Or probably I would say, like, whenever you reach a condition like this, 8 to the answer will always be no. Because now you can not do anything here to make this 8 less than 2. And essentially, this is the idea here. You keep doing operation from 1 to n. If you are able to do operation all 1 to n minus 2 operations, then print yes, otherwise print no. So this was the idea. Like, the idea is, like, you read all the numbers. If whenever AI becomes greater than AI plus 1, you break there. Otherwise, you know that AI is less than AI. Or probably alternatively, you can just and like this minimum will always be equal to, because like you are only dealing it when AI is less than A0. So you can probably do this. And at last you can check if A is sorted order or not. And like that can be one way to do it, or another way you can do it. You make is valid equal to false. And like that would be the solution for D. So this was the idea for the fourth problem. Any questions, anyone? I will then move on to E. Like wait for a minute or so. Okay, like let's move to problem E then. Graph composition. You are given two simple undirected graphs f and g with n vertices. F has m1 edges and g has m2 edges. You can perform one of the following two types of operations any number of times. Select two integers u and v such that there is an edge between u and v in f, and then remove that edge from f. Select two integers u and v such that there is no edge between u and v, and then add an edge between u and f. So like basically you choose two pair. You either add an edge between them or you remove an edge between from them. And you have to ensure that the minimum number of operations such that for all the pair of integers there is a path from u to v if and only if there is a path from u to v. So like that was the problem statement. Just give me a minute. So like the main idea I had here was probably, let's see what's happening here. So like essentially, let's look at what's happening here. Like we have multiple graphs here. Let's take this example 1, 2. Like this is the first graph. This is how f looks like. And then we have another graph 1, 3, and 2 like this. So like our idea is, let's look at, like, this is the bit important part. Like it says there is a path from U to V in F if and only if there is a path from U to V in G. So this essentially boils down to, like, if you look at the all the connected components in F and G, the elements in each connected component should be same. It doesn't really matter what set of edges are there. So the idea is, like, let's first look at the connected component of G. If there is any edge in F which is also in same connected component as G, we should not do anything there. Like I will probably show one more example. Like let's pick me. Let's say this is F. One, 4, 5, 2, 3, and 6. Like these are the connected components here. Like let's pick 1, 4. Let's draw this graph like this. Let's say we have 4 here. And we also have 2 here. The idea is, like, we look at all the edges in F, and you will notice that 1 and 2 are in same component. So you should keep this edge. Let's say orange means we will keep this edge. Now 1 and 3 are not in same component, like because 1 is here and 3 is here. So you will have to delete this edge. Now 3 and 4 are also not the same component. 4 is here, 3 is here. So you will have to also delete this edge here. 1, 2, 3. Like let's say this is 5. 1 and 5 are not in same component. So we will have to even delete this edge. And 5 and 6 are not in the same component. So we will have to also delete this edge. And you notice, like, once we do this, like this is first preliminary phase. You look at all the connected component in G, and any nodes which are in same component, you don't do anything there. And any node which are not in same component, you end up deleting here. So in the first phase, you will end up deleting 4 edges here. 1, 2, 3, 4. And then you look at, like, which are the same connected components. Like this component looks fine. This is 5, this is 5. This 6 must be connected with 3. So you can probably add an edge like this. And 1, 2 must be connected with 4 as well. So you will also need 2 more edges. So like that's the idea. Or one way you can do is probably you count the number of connected component in after removing connected component count in F minus connected component count in G. Like essentially those would be the extra additional edges we need. You can probably try to maintain it manually using a DSO or something, or you can just look at number of connected component in F, number of connected component in G. Their difference is what is the number of edges you should add. The idea is for every edge you add, you will either add between the same two nodes in the same connected component, that does not reduces the number of connected components, and that does nothing. Or you add between two different components. So for every additional edges, you will end up removing, like you will end up decreasing the number of connected components by one. So essentially, this was the idea. Now someone is asking why counting the number of first adding and then removing is wrong. Like I think the main example would be this: 1 2 3 1 3 2, and probably I think, or you can probably try to come up with an example here. I think I will probably do this way. Like okay, yeah, I think the idea problem here might be like in the way you are probably adding the edges there. Yeah, or like I think alternatively you may miss out a graph like this: 1 2 3 1 3. Yeah, I think the same sample when you won't add any edges because 1 and 3 are in the same connected component right now, and 2 is also in the same component. And when you will end up deleting some edges, you will end up deleting these two, and now 1 2 and 3 are in different components, but you need that in same component. And essentially that's the problem here. This was the idea for problem E. Any questions, anyone? So for E, can't we make two cases? If there is no common edge, then the answer is m plus 2, else answer is common edges. No, that does not work. Like for example, you have one graph like this, and you have another graph like this, 1 4. You don't have to add or remove any of the edges here, but there are no common edges as well. Like let's say this is F, this is G. Okay, like I think I will probably not go into the different heuristics people have tried, but essentially the idea was you first deleted and you then added. No, like here, like we don't check paths from each node. Like generally, like DSU is probably a data structure, I would say, disjoint set union. That can probably, if you keep adding edges, that can give you time complexity of n plus n log n. And then it can give you order one queries to find whether two nodes are connected or not. Like you might want to check out user guide to see what exactly DSU is. I ended up skipping what DSU is, but yeah. Like I'm not sure basically how Twitch works, by the way. Like this is probably the first or second stream I have. So like this was the idea for problem E. Any questions, anyone, before I move? Like why this doesn't work? Like the question should be why this should work. Like heuristics are not supposed to work. Yeah, like I think I will probably end up using encoded library DSU. That's one part. So like essentially I have this coder DSU. Like you can probably check one of the older videos I have to see like how to import this library in your local setup, etc. So I first did all the edges. Then I have two DSUs, D1 and D2. Like one is for E or one is for F. First I merge all the edges to find what all different connected components are there in D2. Now I have to first delete edges. Like I move on all the edges. If D1 and D2 are in same edge, like U and V are in same edge in D. Like first I am finding all the connected components in U and V. Then if U and V are in same connected components, then I don't do anything, just rather add that same edge in U and V as well. Otherwise, I am forced to delete one of the edges here. After that, I look at number of connected components count in D1, F count, let's say this, and G count. Like basically, these groups returns me all the set of pairs we need. Like this basically gives me each connected component as a vector of vector. I can probably show you around like how does E1 dot groups looks like. And you have to just look at the difference of those connected component and add those many edges to merge all the groups there. This ends up being like short and simple solution if you have add coded library. Otherwise, you might have to add all the edges there. I think I will come to chat's question once I'm done with discussing all the problems, which is F and G remaining. So, like for example, when you have 1, 2, like let's take this one 1, 2, 2, 3. For in first pass, you will end up deleting both the edges because 2 is in different component from 1 and 3. So your components would look like this: 0, 1, 2 in F and 0, 2 and 1 in the other component, assuming zero based indexing. And then you can see like you have here 3 components and here 2. So you should merge 0 and 2 here to increase one more count there. And essentially this ends up being the idea. Any questions, anyone? I think I have skipped out a lot of things here. Like how do we find groups here and how do we, what exactly DSU, etc. is. And I think this problem was more of an educational exercise. So this was problem E for us. Any questions, anyone, before we move to problem F? Like F and G were on harder side of this contest. I think all the tips and tricks, etc., like I will end up taking at last. Like I will probably keep on F and G first. Problem F is multiplicative array. You are given integers k and n. For each integer x from 1 to k, count the number of integer arrays such that all of the following are satisfied. Length of a is between 1 to n. Each ai is between 1 to k, and product of each ai is less than equal to x. And now we have to count number of different arrays for each x from 1 to k. So this was the problem statement we had. So like the first observation was like notice that x is between 1 to k. So all of these number would definitely be between 1 and k only. And but the n is annoying problem here, like n is up to 10 to the power 8. let's say like n is up to 50, 60, something like that. What will you do? Basically, we have been given a number k and n. We have to count number of arrays, and then for each x equal to 1 to n, x equal to 1 to k, count number of arrays with length less than equal to x and product x. Like the idea is, let's first forget that n is big. Let's try to solve for n less than equal to 50. What will you do? Any ideas, anyone? The idea I would have is dpij as number of arrays of length n, length I, and product j. And let's say for all these arrays, I append y. So like the new length would be I plus 1, and new product would be j into y, right? So we can keep doing our dp like this, like for I equal to 1 to n, for j equal to 1 to k, for y equal to 1 to k, dp I plus 1 j into y plus equal to dp I y ij. And now notice like this can be more than k in fact, right? If both of them are k. So what you end up doing is, let's make it k divided by j. So for all I equal to 1 to n, for all j equal to 1 to k, for all y equal to 1 to k divided by j, you do dp I plus 1 j into k, like new product, plus equal to all the arrays you have so far. And once you have this, like number of elements with some number of elements with product x would be like, you just take sum of this number, whatever wildcard you have, this dimensional array. And like this is the first idea we have. This definitely looks like this k is up to n, this is up to k, and this potentially if j is 1 is up to k, so k, right? So time complexity looks like nk square. Any questions, anyone? Like why this brute force should work first before we try to see what we can do better? Any questions, anyone? Yeah, like then the important idea was, we were claiming like these for loops run in k square time, right? But the fact is, when you do k divided by j, you see like this part is changing always. When j is 1, it is going up to k. When j is 2, this is going up to k by 2, and so on. When j is equal to k, this loop runs only once. So the main crux idea here is like this for loop runs k into log k times. Question is how? Like instead of looking at just taking it as k, if you look at for the first iteration, it would be k times, then k by 2 times, then k by 3 times, up to k divided by k times, right? Like this is generally known as harmonic sum. Like you can put it like this: k into 1 divided by 1 plus 1 divided by 2 up to 1 divided by k. Like this is harmonic sum, and like this value is approximately equal to log k. Harmonic sum. There are multiple ways to prove it, but I think I will end up skimming it. Like dpij signifies like there are, like so far we have constructed a sequence of length I, and their product is j. And then when you add a new number y to it, we get a new sequence of length I plus 1 with product j into y. So like this is quite a famous formula, and this is divergent, but there are different proofs to show like this is approximately equal to log m plus some constant here. So I will end, like this comes up a lot of times. So if I have to say it now, right now our solution is n times the main loop, then k log k the inner loop. This works because if k is less than or equal to 10 to the power 5, and let's say n is less than or equal to 50. But our problem is n can also be up to 9 into 10 to the power 8. And we cannot use the same algorithm here. Then the next idea is to notice that most of the numbers would be equal to 1 only. Like if k is less than 10 to the power 5, if you have, let's say, 30 numbers greater than 1, then their product would be at least be 2 to the power 30, right? And which is greater than 10 to the power 5. So we have at max 30 number not equal to 0, not equal to 1. So my idea would be like, I will look at the same DP here. Like earlier I was running loop from j equal to y equal to 1, right? Let's say I will only add numbers from 2 here. So first I count. Now like let's say now I have a new DP2 ij, which denotes number of arrays I of length I and product j, and all numbers are greater than equal to 2. And even if n is up to 9 into 10 to the power 8, like this value will start having values 0 whenever the length becomes more than 30 or so. So like this was the first observation we had. Like, I think I will answer like how to probably do DS and etc. But once I'm done with both of the problems. So the idea here is like now I have j numbers like this, I numbers like this, some number of ones, then a number not equal to 1, let's say 2, some number of ones, then a number not equal to 2, say 3, some numbers equal to 1, and then a number 4, right? And some number of ones again. Like now, let's say we have placed all the numbers greater than 1, and now we have some holes in between, and we have to put some numbers there. And you notice when you multiply by 1, product does not changes. So let's say if I have 5 numbers not equal to 1, then I have 6 holes. Let's say I put x1 numbers, h1 numbers here, h2 numbers here, h3 numbers here, h4 numbers here, and so on. Like let's probably put 5 here and some ones again here. So if I have put at 5 numbers, I have 6 holes, and what I need is number of ones in h1 plus number of ones in h2 up to number of ones in h6. should be equal to less than equal to n minus 5, because 5 non-zero numbers I have. And again, like there is an NCR formula here, which is known as stars and bars. Like this is again a famous problem we have. Okay, it's not here. I think it's on CPL. Stars and bars. You might want to check this one out. Like for example, it says for an equation like this, x1 xk equal to n, where all the values are greater than 1, this value number of solution is exactly this. And we have a less than equal to sign here. So what we can do is like we can also add a new variable, let's say delta, and say like we can use that delta to make up for sum equal to n minus 5. And this essentially ends up being a solution here. So like the number of solution you have is NCR. Here you have n, basically the sum you need, which would be n minus 5. Here you have sum you need, n. Sum you need plus the number of variables you have. Like you have 7 variables, 6 for the wholes and 1 for the extra delta, and minus 1 here. So this essentially ends up being C of n plus 1 n minus 5. And you can notice like this is also equal to C of 6 n plus 1. So you need this n plus 1 C6 here. Like this, you can directly count the number of ways to place remaining ones. You have fixed all the numbers greater than 1 in your array. And like n is up to 128, so you will have to probably pre-compute some values from the prefix. Like this will be equal to like this, n plus 1 multiplied by n multiplied by n minus 1 multiplied by n minus 2 multiplied by n minus 3, 1, 2, 3, 4, 5 multiplied by n minus 4 divided by 1 into 2 into 3 into 4 into 5 into 6. So you can essentially pre-compute values of all the factorials, and you know that there can not be more than 30 numbers. So you can never have more than 32 wholes. And like this was essentially the idea I had. Any questions, anyone on the idea before I jump onto the solution for problem F? So if I have to jump onto the code, and like overall time complexity would be around 30 into k log k. Some library function for NCR, etc. Like when you have 0 elements, the product you can say is equal to 1. Let's first calculate our DP value for numbers less than equal to 30 or 40 only. I took some 40, 30, probably 25 is also enough. For all I1 equal to less than equal to 1, I plus 1 less than equal to 1. For all j equal to 1, like previous product, and for all y equal to 2, y less than k by j, y plus plus. dp I plus 1, you like this, it denotes you have array with product j and you appended y to it. y into g plus equal to dp I and j here. Like for each number, I start with like we need at least one number, right? Like you can directly say for product equal to 1, you can and erase all of them would be 1. And you start calculating for all product from 2 to k. You first have like the number of arrays to put all the, you have at least u non numbers not equal to 1, and these are the number of possible arrays here. Now you have holes here. Holes would be u plus 1, or you can probably directly plug in the formula we had here. Like this formula is like number of holes plus 2. Like I think we had 4 numbers not equal to 2. So like what you essentially need is ncr n plus 1 comma u plus 1 here, and you can add this to the required value here. Like the n is very big here, so you can probably pre-compute all the values here. Into n plus 1 minus r divided by r. So you can directly take p into f1 into u plus 1. And instead of this, you do this, and you will have all the products. You can print all the values here. So this ends up being solution for problem F. Any questions, anyone? So wait one second. Looks like I'm missing out something here. Like, is it supposed to be? I think let me just check the formula I had. I think I'm something missing out here only. Okay, yeah, this should be n minus r. I think I will come to chat Q&A after. I think this should be n plus 2. Like the array above starts from 1. Yeah. So this was the main idea here. Wait 1 second. What am I doing? N plus 2 minus r. N plus 2 minus r and divided by r factorial, right? And inverse of this only. U plus 1 looks fine. 1 second. N plus 2 minus r. N plus 2 minus r. And for you need inverse factorial of r only. Like this looks fine to me. dp up ui u can be up to 0. Like 0 does not make sense because I am only computing p here. Let's try to see if these values are equal or not. I was expecting them to be equal. It just looks fine. So I must have made a mistake here. 0 and 1. J is from 1 to k looks fine. Y is from 2 to k by j. This also looks fine. Y plus plus. Can anyone spot the mistake here? Like the solution looks fine to me. You need at least one non-zero element. Wait, C is always 0. Okay, looks like some mistake here. PP01 is 1. J is from 1 to k. U up and Y there. I is from 0 to 1 looks fine. Like let's just run this for this example. Y 2 is 1 fine. 2 is 2 0 fine. So the answer for the first test case is 2 and 3 only, right? 2 and 3, 3 6 6 10. 3 6 6 10 looks fine, right? Okay, yeah, just correct. Not sure what mistake I was making, but yeah, that's where we are. So this was the solution I had. Like we do not need a lot of boilerplate NCR stuff here. I think you can probably visit the Discord server I have. Like I think just give me one more problem, then I would be answering chat questions only. Like G is the last problem for today. So this is problem F. I think I will move on to the last problem for today, which is problem G. Today, Alice has given Bob arrays for him to sort in increasing order again. At this point, no one really knows how many times he has done this. Bob is given two sequences A and B, both of length n. All the integers in range from 1 to 2 and exact appear exactly once either in A or B. In other words, concatenated A plus B sequence is a permutation of line 2 n. Bob must sort the sequence as increasing order at the same time using Alice swap function. Alice swap function is implemented as follows. Choose to index I and j. Swap AI with BJ and swap BI with AJ. Like you cannot do it the reverse here. Like you have to index, you swap element of one with the B of other and element of one with the B of other. So this is the idea. So like let's look at some of the samples here as well, like 1643. No, not this one. 53. Okay, I think I will pick this one here. Like let's pick this 5371. This is a 8642. Okay, I think this turns out to be simple. Like you can probably swap. Like for example, now if you let's say you perform an operation here, and let's say you perform an operation here. This 4 goes here, this 8 goes here. Like the new sequence of operations you have become is 4, 3, 8, 1, 7, 6, 5, 2. Like now let's do it this way. Let's perform an operation between these and these. This 5 will go here. Wait, what? Looks like 1 second. One minute. It looks like some function. So we were here. So we were here, like as what we were working on this array 5, 3, 7, 1, 8, 6, 4, 2. The first thing we did was a swap between these two numbers. And then we ended up with 4, 7, 3, 6, 8, 5, 1, 2. Then the next thing we did was a swap between these two numbers. This goes here, this goes here. We ended up with 4, 7, 5, 8 6 3 1 2. A swap between these two. And like let's say we swap numbers here now. This 8 ends here, 4 here. Like we will end up with 8 5 7 4 6 3 1 2. Now notice like we started with one second. Looks like 5 8 8 5 5 8. And then let's probably do some operations here. We will again end up with numbers like this. Or wait, I think I will probably do it the other way. Like let's start with this 5 3 7 1 8 6 4 2. Let's first swap these two. 4 goes here, 8 goes here. We end up with like this 4 7 3 6 8 5 1 2. And like let's do an operation here now. This goes here, this goes here. We will end up with 4 7 5 8 6 3 1 2. And now let's compare. And now we can do one more operation between first I swapped this, then I swapped this. Now wait, my goal is to swap these two numbers here. So here I would want 7 4 again. Yeah, like I'm doing something wrong here. This was my first operation. Now let's do a swap between this. Okay, let's do a swap between these two first. 6 3 7 4 8 5 1 2. Basically, my idea is I want to swap these two and keep the order same. Like now let's do a swap between these two. We will end up with 6 5 8 3 4 7 1 2. Then we do an operation here. Like let's okay. Yeah, like now let's do an operation between these. This 5 8 is 5 8 here. So 5 8 has been correctly placed here. What I have done here 6 3. I want 3 6 here. Yeah, like this is step 1. Now the idea is I can probably make a swap here and here once. I will end up with 7 4 3 6 5 8 1 2. And then I can swap here as well. Like basically the Problem is more about playing between different kinds of operation we have. Like basically, I think I will probably skip it for the sake of interest. But the idea was like if you have this sequence, after some set of equations, you can form it like this: 7, 4. Basically, 3, 6, 5, 8, 7, 4, 1, 2. Like I tried to prove, like basically, like for any two numbers, it was possible to even get the same order without swapping the numbers there. And for that, you needed a third variable there. Probably let's look at it like some cards here. Mm, UV, AV, like probably let's make it 1, 2, 3, 4, 5, 6, 7, 8. If we have this, then first, if I make an operation here, I will end up with 7, 3, 2, 6, 5, 1, 4, 8. Then I make an operation here. I will end up with this 6, 2, 3, 7, 5, 1, 4, 8. Then I can swap numbers here. I will end up with 1, 5, 3, 7, 2, 6, 4, 8. Okay, yeah. So essentially, it's a cyclic shift here, basically. From 1, 2, 3, 5, 7, 6, 4, 5, 6, 7. So the idea is like you can pick three numbers and you can do a cyclic shift between them. Here, like if you started with U, V, W, you can cyclic shift to make them W, U, V. And the idea is like you don't really have a constant between numbers here. Like for example, let's say we have four numbers here. And we can even call it U, V, W. And then if we do a swap here, we can end up with this pair here. One second. U, like let's call them three pairs. P1, let's say P3, this is P2. Then we can move it in such a way such that P2 comes here, P1 comes here, P3 comes here without making any change there. And like this was first observation. And like you can probably try to play around here. And like my main idea was I tried to construct an array C which is in sorted order. Like let's pick the example again. I have 5, 3, 7, 1, 8, 6, 4, 2. The idea is find the smallest number, put this number here, 1, and keep its opposite number 2 here. Then go for 3, like the next number 2 is not available to you. Then the next number available to you is 3 and the opposite pair 6. Then 4 is available to you, but this is in inverted position. So you put 4 here, 7 here, and you variable account like number of inverts you have done, which is now 1, because to put 4 here, 7 here, you will have to invert this pair. Then you look at 5 and 8. The idea is like you put 5 here, you put 8 here. So like I was trying to put numbers in increasing order, and I was also keeping a track of how many times I will have to flip the pair. And the idea was Like here we have to do flip only once to put this number, to put these numbers in sorted order. The idea was like if this flips is even, then I can first make some swap operations to flip the numbers and then try to sort the array I have. And if flip is odd, then if the idea was if n is odd as well, then what you can essentially do is you can first flip all the pairs and then you also flip back whatever numbers you required. Like instead of like basically creating an array like this, you can essentially create its reverse as well. 2 1 6 3 7 4 8 5. And here also, like since n is 4, you will need 3 flips. Had n been even, you could have gotten like the another way even as well. So like this was the idea. Like first try to sort, like just try to find the sorted order you have and keep a count on number of flips you need. You need f flips. That, or probably you can also do is like instead of creating the sorted on the first side, you create sorted on the second side. So you can also have with n minus f flips as well. If any of them is even, you are good. Like you can first make those flips and then try to create a sorted array like this. If both of them are odd, then the idea was to check if some prefix you can make like this and you can revert this part completely. So like can you make this sorted by like 1 2 6 7 8 3 4 5? This was another way to try to see like if you end up with odd flips, can you keep odd flips, like basically find some prefix here, odd numbers here, and try to find if you can form flips here. Like the only thing I have yet to prove is like I think we were swapping it cyclically and the question was like, can you make it equal to like all the original array? Like this was the last bit which I did not try to prove there, and I just ended up being with AC there. Like had the problem in like content of A and content of B should remain same. This was not the condition. Then the problem would have reduced to counting the number of inversion in A and B and try to solve the problem there. And that should have been also been equal. Can you explain both odd case? Okay, my idea was like I ignored all the numbers. I tried to populate numbers here like this. Try to see what minimum I can get. 1, 2, 3, 6, 4, 5, 7, 8, something like that. The idea is if I cannot form a sorted array like this, then the answer is definitely no. The idea is like you will have to place one somewhere, right? So why not just place it as starting and put it opposite pair here? Then you have to place 2 somewhere, but 2 is already placed. So you look at 3. Now you have to place 3 somewhere. So you just place 3 here and place 6 here and ensure like if you end up with numbers like this, then the answer is definitely no. You can never form a sorted array because what you are trying to do is trying to keep it minimum and doing it as well. Like if you try to keep place number, you end up with 1 2 3 6 4 5 7 8. This is not sorted. The answer is definitely no. But if this ends up being sorted, now there are some edge cases like can you get some idea here? And here the idea was like let's say we ended up with numbers like this 5 6, but the problem would have been like the original array would have been like this 1 2 5 3 4 6 7 8. Now here like you have to make one flip like this here, and now you have to check like whether, and you can never get that. Like you will have to always need even number of flips to ensure like the same number of, like whenever you are making one flip you are making another pair as well. So like the total number of flip pair will always be even. Now here we have one, and here the idea was like when I have flipped these numbers, like let's say this was the only flip pair I needed. Instead of doing this, can I just keep it as it is and flip the remaining part here? Hmm. Like basically my idea was to flip this part again as well. Like just completely. Like basically we needed one flip here. And my idea was I will also flip these three pairs again. Effectively, it's equivalent to doing it like this. Just keep it 5, 3, 4, 6, 7, 8, which is essentially just keeping the background flipped, and you can get two flips here. Like the idea was we need one flip here. Let's try to even flip again, like the odd prefix again, odd suffix again. The idea is like if you end up with getting an answer like this, then the answer would be yes. Here, this would have worked because this pair is still fine. But let's say you had a pair like this, where this ends up being 3, 2. Then the answer would have been no. Like the idea is trying to see, like, can you just make a suffix of odd length again flipped back? If it would have been like this, then you can definitely never get an answer to. Like the answer will always be no for a case like this. 1, 5, 4, 7, 3, 2, 6, 8. This will always have a no. And like how did I found these cases? Like I mostly ended up doing stress testing after a lot of Ws. The idea was to try out, create all the 6 factorial, 4 factorial permutations here. Like I tested for all 8 factorial possible combinations here, and then 12 factorial combinations here. And like stress test was the idea to find cases like this. Like the for the odd case, the idea was like to basically see, can I make one of the suffix flip completely together? Like basically finding one pair of even length, where if I keep it like this, then also works. But if I just flip everything after it also, then basically this number is less than both of these, and this number is also less than both of these. And yeah, like this was, I think, problem G. I will quickly jump on to the solution, and then we'll take chat's question and answers. Like what I haven't really tried proving was it's possible to get whatever greedy sequence I get here. So read all the pairs as input, try to see if yes, print it, otherwise no. And the idea was like I read all the numbers from all the pairs. I keep opposite pairing numbers here. And for all the numbers in increasing order, if that has already been taken, ignore it. Otherwise, put that number in the opposite pair. And if your new number is more than the other number, you immediately break here. Like this is for the cases where we have like this 1, 5, 2, 3. Like for the answers like this, the answer will always be no. And like once you are done with this, I also maintain like the number of flips I have done. I keep flip odd. If n is also odd, then like if n is odd, like first, if we were able to form a valid C, if n is odd, then the answer is always true. You can just flip the complete array again. Otherwise, if you needed odd number of flips, the answer is true. Otherwise, now we have to flip one of the suffix as well. So what I do is like for each odd length suffix, I try to flip one adjacent pair there and check if that is greater than that or not. Or another way to do is it like max of, or like alternatively we know, right, the numbers are in increasing order only. Cj minus 1 dot y is less than Cj dot x. Basically, like the idea is maximum of both of them, Cj minus 1 dot x. Yeah, I think just 2 more minutes and then I will be answering chat's question and answer. Like this is the only case when we can flip odd case, and that was the solution for G. Like what I haven't really tried proving is like why like cyclic shift, and this makes sense. Like the main idea was like when you do a cyclic shift, like the number of inversions in the array parity remains same. So probably for the last parity, you can just flip one of the pairs to get whatever required parity you want. So like in the initial submissions, I had like the parity of inversions in both A and B should be same. Like, but it later turned out like that is not the case. Like I was directly printing no when number of inversions in A and B were not equal. Like this check does not work. This check is required only when we have been given that number of elements in A and number of elements, like the element content should remain same at last and also sorted order. But that was not required. Like that's why like you don't really need an inversion checks like this. The idea was like when you try to make C like this, it will always turn out that the last number will always make up for it. So I think this was all I had for the contest. Any question on the any problem in the contest? If not, then I will probably answer chat's question and answer. So I think this was all we had with chat. Like I think there were two major questions in the chat. One of was like any resources to, okay, the brute force solution I had, sure. Wait. Mhm. Like it is in fact available. My idea was to assume that we can always make one of the array sorted. The idea is like, can it leads to another array sorted there? So like this is the brute force solution. The idea was I have array C. I tried to create array B with some pair of flips there. G denotes number of flips I did. When I reach index I, number of flips should be 0. And then I was checking if I make one of the array sorted, what happens with the other. So like first I make some even number of flips, and then I assume that I can always make one of the array sorted. Can it leads to making another array sorted as well? The answer yes or no. Like this was the only brute force I had, and that's what I ended up testing here. Like, and I had some faith like this works. Like the idea would have been like you could have tried out making some flips as well, some memorization, etc. would have also helped you there, but that was what I ended up doing. Okay, so one question was like, I'm beginner in CP. What should I do? Basics of DSA. Like, I think the solution always remains same. Like, I first end up advertising my Discord server. Like, you can join the Discord server I have. Like you can check roadmap to red channel here. Mhm. Here are some advices on what beginners should do. Like the first advice is participate in all contests. Try to read editorial and then try to solve problems later on. And then the question is like my suggestion is participate in all the Adcoder ABC contest. Like you shouldn't discuss that. And then if you looking for some standard problem, either you can look at USACO guide where there are different sections based on bronze, silver, gold, platinum. Bronze is for absolute beginners. Platinum is harder than D1. So based on what your rating is, you can pick one of the division here. Let's say you have pick the bronze division. Like around 99 problems are there, which says introduction to data structure, simulation, basic search, sorting, searching, geometry, etc. are there. And similarly, if you look at gold is between D2 and D3. 360 problems are there. You have modular arithmetic, combinatorics, DP problems, graph problems, etc., trees, and you can try to solve these problems. You can also alternatively pick CSCS problem set. There are around 200 different problems here, some standard problems, which you can try to solve. And there is a book as well associated with it, Computer Programming Handbook. So this is one of the book I end up recommending folks here. So you can probably read this book as well. Around 300-page books. And then the question is what I was doing when I was expert or below. You can read it here. What I was doing when I was targeting 2100 rating, you can read it here. And like one ultimate tip is to get better at X, you should do it X. And some chat Q&A I did even for ICPC regionals, you can check there as well. This is what if you are complete beginner, what you should do. That was first question. Yeah, then next question was like what some resources I have probably for CPP if someone is starting out. Like my recommendation is depends on what your goal is. If your goal is competitive programming, then you should just look at STL basic standard template library and then you can start with there. Is there anything? I think this book should have covered it. Yeah, like you can just refer this section here. It has array, set, map, iterator, basic C++ STL, and this one chapter should cover everything there. And this should be enough for you to get started with competitive programming, and you can discover more nuances there. Like you don't need a lot of C++ knowledge to get better at competitive programming. So only like what basic data structure like the library supports is more than enough. Can you check? Can't understand. Okay, I will probably skip the previous contest. This was one. Like Himanshu, you can probably ask your question as well. Need help with given array count number of signals. Okay, like I think like your question was like, can we probably solve it for harder constraint? Like solving it for harder constraint, like product you need an array of n integers whose product is divisible by k. I think this problem has appeared a lot of times. Like you can maintain like the factors of k and try to do a DP based on that only. How to get out of expert, stable, candid master? Yeah, like I think my recommendation would be to do a lot of virtual contests, try to solve problems there, and see what you could not solve in the contest, solve it later. And I think if you are expert, like you definitely know the basic stuff there. Like the only thing probably remaining is you have to grind a lot of non-standard problems. You can start with USACO guide to begin with, and virtual contest would be my recommendation. So, any questions, anyone, before I call it a day for today? And thanks everyone for joining today. So, yeah, like that's where we are. And Oh yeah, like tomorrow's contest, Jingli will become tourist. I think before that, Mike will end up adding a check like you should have username there. So yeah, like I think probably lately I'm getting a lot of busy. So like probably I will not do it for every contest, but occasionally I will end up doing it. How did you manage DSA and Dev in second year? Like I think it's always about priorities. Like I think there is no reason to choose one of them. Like my always recommendation is to do both of them. It just depends on like how much you do which field, and like you will have to manage it at the end of the day. Like if you want to succeed. So thanks everyone for joining today, and I think that's all I had for today. Thanks a lot.